Hello. Today I'm gonna be tackling this everybody codes thing. Heard about it from a colleague. Similar to Advent of Code, but first year it's been going on. Apparently it's got 3 quests and 3 parts of the question, which they refer to as quest. And leaderboards have a head-to-head mode that only compares since the time you opened it, so it's a bit more friendly to groups that all can't hit it as it opens. Here we go. Blah, 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 blah. Example based on the following notes. So I guess put that there. Total, I need 5 potions. Let's see. Okay, so we have these bits, and let's see what these things can be do. Defeat all enemies using the fewest number of potions. A, no potion. 1, 3. Okay, I bet I see what's going on. For car of notes, let used equals 0 if car equals A. Hold on, A is no needed. B is B. Potions use plus plus. If character receive, potions use plus equal 1. What are the other characters? A, B, and C. That's all I get. Okay, so what's mine? For example, based on the following notes. A, B, B, A, C. A, B, B, A, C. Oh, my notes. Here they are. Copy. Console log sum. Just gonna put them right here. Probably gonna be really big. There it was. So if I were to directly target this, wasn't super prepared. PXTSX 2024. Come on, go in the folder. Go in the folder windows. Yes, install the thing, please. Probably save this. Great. I'll just write a thing. Boop. Okay, that should be enough. Let's Quokka start. Show me the output. Oh, I'm not returning this number, am I? No, I'm not. No, not position offset. Potions. There we go. Expected 3 to be 5. Well, that's awkward. Let's look at the real one. 641. Well, I expected 3 to be 5. Dang it. It's supposed to be, what, by 3, right? Save that. Go to the end of that. Come on. Keep scrolling. Keep scrolling. 1289. But the enter key does not submit that. There we go. Round 2. Okay, this time kingdoms sometimes join in pairs. Okay, A, X, B, C, D, C, so there are pairs. I have to split them into sequences. So let's sum 2, and yeah, I'll just take this one. Don't do whatever I just clicked on there. Sum 2 for this input should be, oh jeez, all my new lines got lost. 28. Okay. Let's see what we get to do this. So, how are the pairs determined? Is it literally just every 2 characters? Okay, I like it. Single ancient, 6, 2, and 4. Is it literally just additions? When 2 pair up, you'll need 1 more per creature than on a 1 on. Okay. So, let's see, for 0 I less than notes dot length I plus equal 2. So increment forward by the pairs. Pair equals notes I plus notes I plus 1. Guess we'll still need potions used, but we don't do this anymore. Let's see if there are any new rules. So D requires 5. So AX. The X symbol shows an empty spot where no monsters appear. Okay, so AX, B, C. 2 for the beetle, 4 for the cockroach. B required 1, C required... Okay, so when they pair up, they take more. Cost needed. Potions needed, so let me just create this mapping, which I should have done a while ago. A1, B, well, A0 actually. B, B1, C3, D, what's the new one for delta? D5, okay, there we go. So, let's get it. What's the X do? The X, so, means no pair, and that X can be anywhere. Okay. Cause powered up equals pair dot includes X, not includes X. Okay, so const. So let's say potions used plus equal pair. Well, we'll go potions needed for each member of the pair plus potions needed for the other member of the pair. There we go. If are powered up, then potions. Then if these are positives, then increment 1, right? Sometimes, ooh, this is tricky. Does the A require another one? One more potion than creature. Yes, 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 yes. Okay, so if are powered up, then if potions, well, it's just one more for each. So potions used. If I could spell the word potions, I'd be getting somewhere. Plus equal 2. Okay, we do that. This is an and equaling the thing, so 0. Doesn't exist in here. X, 0. We good. We got 25. Give me my input. Test 2. This is where things probably go wrong. Boop. And I did a typo somewhere here. Great. To the end of the line. 5506. 5506. Submit. Nice. Okay. Part 3. So here we go. Well, might put the same for all of them. It's not. So let me grab this. Drop that there. This is sum 3. Make another example for the third one. Sum 3. Give me the inputs. I wonder if this is the one where my splash damage theory will come true. 30. Okay. Okay, let's make our sum 3 function now. Let's see what we need to do. Your final round, also groups of 3. 2 potions per creature. Okay, this is a nice reusable function that I did not really implement. So 0, 1, 2. So if I just be a little cheesy here. Plus, and I will need to adjust some things. Because my extra logic assumes that, hey, if you have an X, if you don't have an X, that means both of the others are good, but that doesn't work because you can have 2 X's, can't you? Yes, you can. Okay, so for cost cart and pair, if cart not equal X, I guess it's of, not in, because I'm not writing in Python. Okay, and what we want to do is say potions used plus plus. No. 22 to 35. Okay, is there a new creature? 2 extra potions per creature. So it's plus equal 2. Supposed to be 30. What did I hit? I hit 28. Okay. Maybe my groups are wrong. Let's look at my groups. Well, I'm calling them pairs, but they're groups. Ooh, I do not want to be looking at that one. Let's focus on the one I'm trying to fix. XBX, AAA, BCD, XCC. Okay, if character is not X, then potions used goes up by 2. So 1 plus 6, 15, 8. Great, let's look at that. Let before equals potions used. And then it's potions used minus before. So we get to see what difference we're doing. 1, 6, 15. Aha! XCC. So the XCCs are the one failing. Y. C is supposed to be 3. For tough battles, you'll need 2 extra potions per creature. 1, 6, 15, 8. 1, 6, 15, 6. So this one's 8. Why is this one 8? Well, because C is 3. So 1, 2, 3, 4, 5, 6. Which is what I'm logging. If powered up means there's not an X. Oh, but this logic doesn't hit because these are a pair. So it's so it's 2s and 3s. Oh. Okay. Cause how many in pair? Which I guess is let how many in pair equals 0 if paired index of X let X count equals 0 car of pair if car equals X count plus. There we go. So we know how many X's there are. Now, if cost extra potions per monster equals X equals 0. So if there are 0, then you get 2. But if X count equals 1, that means you go 1. Otherwise, it's 0. There we go. Okay. Oh, jeez. Okay. No. 1, 6, 15, 6. No. Okay, let me just zoom to the interesting part. So 1, 2, 3. So what is this? 2, 3, 6, 9. Okay, now we're looking at the problematic one. Please continue the trial. Okay, so console log X count. Okay, we love that. Console log extra potions per monster. I think my focus got lost. Nope, focus is still on this one. So it's 1 extra potion per monster. Now we already did the math here, so let's log that again. It should be 6. Yeah, 6. So if R powered up, get rid of that conditional. I didn't want that here. 6, 8. Okay, we got it. Drop this down to 0. That's not a 0. Okay, something is really chugging my CPU. Let's drop all these consoles and all these things that aren't being used. Good enough. Hit it for the real one. Remove from filter. Go to end of line. Scroll to the end of the line. 27,843, 27843. Okay. That was that done. Going to quickly glance. Okay, yep, just everything was good. Yeah, so that was a rush. Problems solved, or answers generated, rather. Yeah, lots of room for improvement, both in the code and how I'm getting my answers out. But this was cool. What's this button do? Unlock parts of the Oracle by solving these parts of the Oracle. This little. Oh, I bet that's kind of like a bar that gets filled in triplicate. And since I got all 3 bits, it's full. I don't know. Yeah. Looks neat. Cool. Global, local. What's the milliseconds mean? How fast you solve each part globally can count from the time point it was released. Oh, okay, sorry. This is minutes, seconds, and milliseconds. The font color being different. It's like, this means something else. No. So I took like 600 milliseconds to open it, or 500. Cool. Yeah, and that difference is all through. Looks like someone else beat me to number 1. Completely understandable considering how unprepared I was to take in raw input and spit it out. 49. What's this? Ooh, it's a graph. Oh, cool. This is the entire thing. So we've had 171 people in 15 minutes. Nice. Love it. What's this? Oh, got all names here. Cool. Wait a minute. Why am I first if I didn't... Oh, this is all things? Oh, it's total. It says total right there. No, wait, no, I didn't get... Oh, it's for the entire quest. Yeah, part 1. 3 seconds behind. 3 minutes ahead? A minute ahead. Hey, looks like we're gonna have a friendly competition. I love it. Cool, how's head-to-head work? Oh, you just put random people's here. I guess I'll put the only username I've seen. Oh, nice. This is the comparing how long it took since you both opened it versus global times. So it's a little bit more time zone agnostic friendly. What's this? Oh, it's my GitHub. Countries. Ah, cool. You support your country, built-in teams. Nice. Oh, you get the ducks. Oh, that's beautiful. Are there any, like, Easter eggs in here? Because in the advent of code, when you do the entire solution, they give you a little... Okay. Caret positions. Oh, that might be useful for some problems. Cool. What's this button? Oh, thanks. They downloaded it. So yeah, I love it. And now I will do 2 things. I will not import that. I will commit my changes as is to show what I solved it with. Git ignore. I should poke something in the git ignore. There we go. Add. I don't really care about commit messages. They're good enough. And yeah. So, 2 things I want to do. I want to clean up these, because this was a little bit gross. And then I want to clean up the actual functions. Not in that order. So, let's... I believe what I can do is I can make a generic function that will take these in and do it based on an arbitrary group size. But before I do that, I would like to... just for posterity, make sure it was clear what these do. So let me skip the real ones. go through the examples. There we go. So for the initial one, each of these... I probably should read the story. I did skip it a bit. Okay, so we're throwing healing potions on the enemy? Cool. Protect the crops. Love it, love it, love it. So we're given a string, and a string contains a number of characters, limited initially to A, B, and C, all uppercase. Each character represents a different type of enemy that must be defeated, and the different creatures must be defeated with a different amount of potions each. So the bees, or the badass beetles, require 1 potion, while the creepy cockroaches require 3 potions each. So A, B, B, A, C, much like the breakdown, you don't need any to defeat the ant. You need 1 for the beetle, 1 for the next beetle, so your running total is 2. 0 for the next ant, and then 3, so 0, 1, 1, 0, 3 is 5. And that is exactly the algorithm that does here. We set up how many potions we've used, we remember that, and then we go through every single character. If it's a beetle, we say we use a potion. If it's a cockroach, we say we use 3 potions, and eventually we return the total number of potions used. I think that's it for that one. Next one, you get another kind of enemy, diabolical dragonfly, which requires 5 potions, and in addition, they join into pairs. These are always pairs of 2, where when they're not paired up with an enemy, it's given a lowercase x. So AX is just an ant, BC is a beetle and a cockroach, DD, 2 dragonflies, etc. And the new rule introduced was that every time a creature is joined with another creature, they require 1 more potion to be defeated. So if 2 beetles join together, both of which normally require 1 potion, they now both require 2 potions to defeat. And as we'll see, the rule continues. If 3 beetles come together, each of them require 3 potions. And in a universe where we really are in the apocalypse here, if there are 4 beetles joining together, each of them require 4 potions. So yeah, I believe that specific algorithm, or that heuristic, is number of pairs, a number of members in a group, because it's not really a pair, then that amount times the number of members in the group. There's math to determine how many extra potions are needed. But of course, the X's are ignored. They are placeholders for nobody came to the party for them. Part 3 is where it goes to the next iteration, breaks it into groups of 3 with the exact same addition rule that I described. Yeah, I don't believe there's nothing more there. The way I did for the second one, please be quiet, was I checked if there were any X's in there. I added whatever potions were needed for that character, which for the A and the X were 0s. And if there was not an X, that was a weird way of calculating, there are 2 in this group, then straight up just add 2. And I knew I could add 2 because no matter what it was, it would require an additional potion to defeat. So even the ant, which usually required 0, once it was paired up with someone, it requires +1 to defeat. Which, me using this kind of cheap trick to get this one working, meant I had to effectively rewrite it for part 3, where I have to count how many X's there are, and then again, this is why I didn't do the math, but the math would be against the group size, how many X's to what the group size is, and that would consider how many additional potions are added for each character to defeat. But yeah, my first challenge is to write a generic one, which I will call function calculate needed potions. Ooh, plan needed potions. Potions, and what do we have here? Incoming creatures. Incoming creatures, string. Then what are we calling these group sizes? Group sizes, I guess. Group sizes. Number. There we go. Now let's just throw this in here. Da-da-da. Good enough. Let's make some good names. And let's break this effectively into this loop, because I want this to support any group size. Plus equal group sizes. Now I'm going to do some precondition logic here to make sure you just don't provide any arbitrary stuff, because I'm not handling weird inputs. So if incoming creatures dot length modulo group sizes not equals 0. Basically, if you give me a string of 9 creatures, but then you say the group size is of 2, like, that's invalid input. I ain't gonna handle that. We're not in Python. Boy, that is not what I want. Oh, it's error. Again, I'm not in Python. Good enough. Now let's calculate this effectively by just grouping up all the characters here. And I think what I'm going to do is probably, if I was thinking at all, I'm going to ignore the X's. And it will be the number of creatures in this group compared to the group size. That will allow me to determine how many are missing, how many are present, all that fun stuff. So let group equals, I guess we can do some bad stuff too. Cost group equals incoming creatures, slice I plus group sizes. I think this might be it. Let's chuck this away. I just want to make sure I got those bits working. Let's take this Sun2 to say plan needed potions, group size of 2. Turn Wallaby back on because I'd like some alive output. Expected 0 to be that. Yeah, we know. AX, BC. Okay, we have our group sizes correctly. Now we're going to do a little cheeky thing here. Get rid of all the X's. I think since we're using on a string. There we go, we have no X's. And now we need to determine the increase. So what is extra potions needed per creature? That's a great name. Cost extra potions needed per creature. I think that's group.length minus 1. Let me drag this down. And let's see if that output looks correct. So for this one, you need 0. You don't need any extra potions because he's all alone. Very sad for this ant. For BC, yep, so the math was simple once you slowed down, and it's always easy when you slow down. So now we have to add up how many potions are needed for each creature, and I think this map here gonna keep using it. Rename potions needed by creature. I'll leave the X in there. It's not really a creature, but it breaks my other code. And I'm gonna rename this symbol too. Potions needed 0. And for const creature of group, let's do potions needed plus equal by creature and creature. And we just straight up add to potions needed this extra number. And it's not working. Yay. 25 needs to be 28. Why? It's always the question. Well, I was pretty confident in my group and stuff, so let's look at... I guess I need the diff, not all of this. For equals potions needed minus before. Nope. So we see the ones needed for each group. We just need to see the group. Okay, let's go cheat and look at their 0, 6, 12, 5, 5, 0, 6, 12. The extra. Where'd the extra go? Extra, hear all about it. Why am I not hearing about it? Per creature. This one's multiplied by the group.length. There we go. And really, to be more in line with like the story, like the order of operations, it happens right here, but not like that, the other way, because it's per creature. So we do it per creature. Math doesn't care, but this is more in line with the manual algorithm. I love it. And it works for this one. I should also put... Yeah, let's drop all these skips since these are no longer needed. I'll be doing a struggle now. And yeah, I'm going to say goodbye to all our old functions, because our new ones should work perfectly. That's how much confidence I have. Group sizes. 1. Boom. Not going to do it on the real ones, because I haven't put their numbers in. I think this one's a group size of 3? 2? 3? 3. Great, it's already broken. Gonna pretend I'll just about get live. Great, so let's focus on this one. Let's do all our exact same logins again. So console log creature group extra potions needed. Oh, I forgot the regex doesn't do the all of them. Where do I need to put the thing? Here. There we go, and it's green. Regex, not even once. Okay, so that one's working. Now I should be able to put in the other ones. I mean, they work once you put in the group size, which is all the way over here. 1. 2. And a 3. We have them all being logged accordingly. I'm pretty happy with this. I'm gonna rename this one. Change case to camel. Thank you. You didn't do the other one, buddy. There we go. I'm just gonna shove this super customizable. In case you got some crazy creature coming in, you know, you don't know, they just got super mutated. You can handle it now. Okay, so now let's clean this up a little bit. Describe. What did we call these? Parts. Part 1. And these two make it in there. Example. And then, I know these inputs are unique. At least I believe they're unique. Yeah, your notes for this part. Okay, and they're calling them notes. Interesting, I like that. Yeah, eventually I'll do the same as I do with my admin code repos, make a thing that automatically puts it in like an input.n file with like an expected text file or something to that degree. But for now, I'm just gonna shove it here. Expect to be 1. It's gonna fail because it's not 1. Don't die me now, Wallaby. It died. Let's focus, maybe? No, it died. It's okay, we'll just pull out Jest. It'll be able to run it. There we go, 1289. Also turn on word wrapping. That's a concept that would help. Love it. Let's do the same to the other two. Part 2. That's the one that goes there. Notes, save it, run it. Why is Jest on fire? Give me my play button. Oh, I'll just click that. 5506. Love it. B 5506. There we go. Let's do it once more for part 3. Oh, I didn't put the notes inside of the part. There we go. There we go. Yeah, let's run it. Get the actual output. 27,000, right? 27,843. 27843. Add that accept to the beginning. Expect. And it's ready to go. Technically, this should be straight up parameterized test. And I will probably throw something more frameworky together for tomorrow, or whenever I choose to do this, because it's not. The global leaderboard is global, but you can do it based on whenever you open it. We should also run a pillar test up here. One group. Not. There we go. Planet potions. A, B, C. A, B, C. You say you have group size of 2. I will expect an explosion here. There we go. We get the error. To expect. There we go. To throw. I think that'll suffice. Love it. Let's get Wallaby cranking again. Everything is running. Everything's passing. Tokenizer gave up on that one. That's okay. Yeah. I think this is as far as I will take it. So once again, what this does, let me focus on a group size of 2. There we go. Is this goes through, and first it makes sure that these are divisible. So that way, for example, if you're asking for ABC and you say this group size of 2, it would work for AB, but it wouldn't work for C unless I wrote some logic down below, which I could, but I'm too lazy to. And if you're according to the problem, that would be an invalid input anyway. So I'm not handling that. And then I'm iterating through them by the I is the beginning of the group, and I'm only iterating not by 1, but by whatever the group size is. So if it is 1, then it's always 1, but if it's not, we can see 0, 2, 4, 6, 8, where will show up. There you go. So where 0th index is the beginning of A here, 2 is the beginning of the next group on B, 4 is the beginning of the next group on the first D, 6 is the beginning of the next group on the first C, and 8 is the beginning of the last group on this X, which if we were to console log the groups we're actually extracting, here you can see that, and we're just using the old slice to pull out a substring from the initial string. Could have used substring. I think it literally is the exact same signature. It's just both strings and arrays have slice, so it's nice. We also could have just simply iterated over them. It's like we are creating extra space in memory for no real reason aside from the console logability of it. But I like console logging things. If we hadn't done this, we would have to, if we didn't want to do this, rather, we would iterate through all the creatures of the group with a nested loop here, a J loop, for example. And we would need to be doing 2 things, counting the number of creatures and incrementing the potions needed by that creature. And then based on the number of creatures in the group, we would calculate this. So it'd be number of creatures in group minus 1, and then we add this times the number of creatures in the group to the potions needed. All very doable, but this way is a bit more logical to follow based on the description of the problem and how a human would break it down on pen and paper. So then once we do that, we're like, hey, we don't care about the X's. So if I were just, you can see we only see 2 differences here. The first one that has an X in it, we get rid of it. So we get rid of the X there, which, as a reminder, the X, the lowercase x, is a placeholder for this does not, there is no creature here. That's how they represent it. Which means that we ignore them. And then the extra potions needed per creature is calculated based on how many creatures there are in the group. So we can see for a group size of 1, you don't need any extra potions. For a group size of 2, you need an extra potion per creature. For a group size of 3, you need 2 extra potions per creature. So that math I was saying earlier for how this is calculated is, well, you're kind of looking at it. It's the number of creatures in a group minus 1. And if you want to go further, the total extra potions needed for a group is the number of creatures in the group minus 1 times the number of creatures in a group. So it'd be like, in this case, when it's a group of 2, you need 2. I'll just show that off. Times, I think math will do it in the right order. No, math will not. Operations go that way. There you go. So you can see for a group size of 0, you don't need any extra potions. For a group size of 2, you in total need 2 extra potions. Again, mathematically you can do these tricky, fancy ways like this, but it's not the logical way that the algorithm would be followed by a human. And then yeah, the next part is going to each creature and being like, how many potions do I need from you? And that is defining this hash map up here, or JavaScript object, where you have the creature identifier and how many potions are needed. So the ant needs 0, the beetle needs 1, cockroach needs 3, and the dragonfly needs 5. So you figure out how many that is, and then as it's a logical path, the way it's being described, you go ahead and add how many extra potions are needed per creature during that there. Then finally you return the actual thing you've been counting this entire time. So yeah, that is the problem. That is the brute solutions. That is the clean solution. That is the clean solution explained. That is the test of passing. What I have not yet decided what I will do is any form of extra on this, like visualizations or such, but it's nice. I think I'm good with it. I could see this turning into a nice, a boring little game or something where it's like, oh hey, you're presented with a group of creatures, throw the correct amount of potions at them or something, and the quicker and more better you get at recognizing, basically doing this math in your head, like the quicker you can get through them, you get penalized for throwing too many potions. I don't know. Just thinking of ways to make it a little bit more interactive or fun. Yeah, we can also go kind of animated breakdown of looking at it, making a pile of groups, having them queue in, watch the math move around. Yeah. All cool ideas, none of which I am committing to or have the time to commit to. But hope that has been fun and or informative for anyone watching. Always a pleasure. Bye-bye.